You got it? Did you get it from listening to what I was telling this group, or did you just get it on your own? Did you really? Well done. All right, well, let's see. So for the first one, we have r of t is 2 sine, 2 cosine, 4 sine squared. Find t of t. T of t, oh my gosh. T of t, of course, is r prime over the magnitude of r prime, right? So your t of t, there's your r prime. There's the magnitude of r prime. I cleaned up the magnitude of r prime by saying that 4 cosine squared plus 4 sine squared is 4, right? You don't have to, but it sure makes your life a lot simpler. So there's the magnitude of r prime, and then there's your t of t. All right, so there's my t of t. Isn't that lovely? Part B says find a parametric set of equations of the line tangent to r of t at the point P, which is 1, root 3, 1. So what two things do we need for an equation of a line?
A point and a slope.
A point, and normally we say point and slope, so now we say point and a direction vector, right? Okay, so our direction vector could be t of t. Honestly, your direction vector could be r prime, right? Because t of t is in the same, is always parallel to r prime. It's just that t of t is a unit vector, right? T of t is like the unit vector for your r prime. Does that make sense? Because it's r prime divided by its magnitude. So it's going to be in the same direction as r prime. So if you want to use r prime for your direction vector and keep your life simple, you can. But if I ask you for t of t, you still have to give me the whole thing, right? Okay. So for the equation of the line, so first of all, we need a t, right? So let's look at our function. Can we figure out a t? Because they didn't tell us a t, they gave us a point, right? So what we know is that oh goodness. I'm getting the... All right. This is the first time using the new thing. This new... Okay, let's try this again. I'm going to unplug. It's in. Did it go to green? Or is it still flashing? Oh my goodness.
Have a pizza party instead.
All right. So I'm going to write on the board. And I'll just talk it through, and it's a good thing that I pre-typed all the answers in advance because I can't write on the board right now on the smartboard. I got to talk to the Lakeside people to see what to do about it. Okay, so let's just do it over here. We can adapt. So what we get is we know that 2 sine t equals 1, so sine t equals a half. Right, so we kind of have an inkling of what the t is going to be. 2 cosine t equals root 3. So cosine t equals root 3 over 2. Oh gosh, they're both positive. Look at that. And then sine squared equals a fourth, right? So what do you think our t value would be? Pi 6, right? Okay. So since they didn't give us a t value, they gave us a point. You got to figure out your t value. All right, so now we plug pi 6 into r prime. I think on here I probably plugged it into t of t. Okay, there's me like explaining the whole t equals pi 6 thing. The curve passes, blah, 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 blah. So the direction vector, so root 3, negative 1, and 2 root 3. So I just plugged it into r prime, right? So 2 times the cosine of pi 6, which is root 3 over 2, so you get root 3. So negative 2 times a half would be negative 1, and then 8 times a half times root 3 over 2. So 8 times root 3 over 4, which is 2 root 3. So there's your direction vector. So you have your point, you have your direction vector, and you write your parametric equation. So it looks like everybody got those. I don't know why I spent so long on it when you already got them. Wait. Oh, I see. Okay, I saw that that's all, folks, and it made me nervous, but it was over there. Okay, good, good. Oh, did you guys just take 2 boards? Oh, and you wrote it over there. You did it twice. So you guys use T of T because you got those over 4 things, but that's okay because they're all scalar multiples. It's fine, and you guys are fine. Yeah, 100%. All right, well done. Easy peasy. Number 2. All right, so number 2, I'm gonna do nothing. So number 2 says find n of negative pi fourths if RT is cosine t, 2 sine t, and 1, right? Okay, there's a little trick with this one. So if our R of t is cosine t, 2 sine t, and 1, then our R prime is negative sine 2 cosine 0, right? So do you remember yesterday, towards the end of class, I said, hey, if you have a 2-dimensional vector and you need a vector perpendicular, you can just flip them and change the sign, right? Yeah, yeah. So this is just using the trick, right?
The one that we skipped over.
Like these on the test.
I don't know what's on your test.
We literally skipped over this one.
Okay. So anyway,
you don't have to worry about this.
so how do you know, are they both, so when you flip and change the sign, which one do you change the sign up, right? That's what I was talking with the middle front group today about. Well, if you think about it, regardless of the R prime, the magnitude of R prime is going to be always what? A magnitude is always what? Positive, right? It's a square root of a bunch of stuff squared, right? So a magnitude is always positive. The derivative of that, when you do all your quotient rule and stuff, it's still going to be positive. When you have a root, so no matter what, you're going to have, so 1/2 times the guts to the negative 1/2, the guts, but the guts are all positive. It's all going to be positive. So really, it's R prime that determines the sign for R double prime, right, which is your n of t. So if you think about the derivative of negative sine, the derivative of negative sine is negative cosine, right? The derivative of 2 cosine, well, that's going to be negative 2 sine, both negative, so I'd make a negative. But anyway, that's what I would do. So I would flip them and change the signs. So there's my magnitude, there's my t of t. My n of t, so isn't that fun? Yeah, so just flip them, change the signs, and yeah, it's cute over its magnitude, although my magnitude is flipped around, but it's the same thing. Anyway, so n of negative pi fourths plugging in is the vector negative 2, 1, 0 over root 5. So let's see how close we were.
No, we canceled those 2 things at the top. They're stacked on top of each other, but we forgot that there's subtraction.
Oh, there's subtraction. Yeah, you can't do that. Yep. Yeah, the algebra of these gets really, really, really hairy. Yeah. It makes you long for the days of last year when you used to complain because you had, 2 plus 1 over 3 over 5. I don't know how to clean that up. See, now you're like, oh, I wish it was still that. So I don't think anybody got it. But that's okay. Just check.
So from T of T to N of T,
Yes.
you don't have to do anything with the denominator?
So what n of t is, it is a unit vector in a direction perpendicular to t of t. Right? Okay. As long as you're in a 2-dimensional plane, it's going to be the correct vector. And this, so the magnitude of this is actually the magnitude of this, because you end up with 4 cosine squared and then sine squared, and it ends up being the same magnitude. So if you're in 2 dimensions, I'd have to double think that to see if it's always going to be true. But no, it will always be true because you're just reversing them, right? So if you just reverse and change the sign, you'll have the same magnitude no matter what, because you're still going to have this squared plus this squared and square root. Yeah.
Then you're in 2 dimensions.
No, and you're in 2 dimensions because that z value is 0. Yeah, kind of a trick. That's kind of evil. That is kind of a trick. But, you know, it helps you remember, oh gosh, I can do a trick. Yeah, let's not go there. Yes. You want me to do it algebraically? Not going to happen today. So, all right. I actually don't mind. I enjoy, to me, like doing a big, giant, crazy long algebraic problem, if I have the time, right, is to me very relaxing. Like that to me is just kind of, it is. Like, okay, Aha, do you agree with me? Oh. So like, if you're just, like, if you have nothing else, like, oh, I can do this big algebra problem, and as long as you have enough paper and enough space and some time to kill, to me, that's just kind of, that's calming. Right, Rishi? Someone agrees with me. You guys aren't admitting it, but I know there are people in this side who agree with me. Okay, see, there we go. I've got a couple. Danny. Yeah. Yes. Okay. Can't go so.
On the test, the problem is long. I use scratch paper. Like I know I'm new to it on scratch paper. Like I waste so much paper, right? Like I spend over a page and a half on just one question.
Yes, you may use scratch
You
paper.
give us like 2 pages of space.
At least no 5.
Okay.
Not again.
It's PVA again.
PVA.
All right. So we're doing some PVA today. Some in 3 dimensions, some in 2 dimensions. Some of it is going to feel a lot like physics. So we're going to take a formula that you probably learned in physics, and we're going to do a little bit of calculus with it. All right, so today we're just going to go back and revisit velocity and acceleration with vector value functions, and then we're also going to talk a bit about projectile motion. All right. I have the correct section up. Okay. I'm so ahead of the game. All right, and I know what we're doing tomorrow. And I printed your quizzes. I'm getting there. All right. Okay, a lot of words. Just hold off for a minute before you start trying to copy everything in the world. So if the position vector is your r of t, then your velocity vector is r prime, right? Because velocity is the derivative of position. And your acceleration vector would be r double prime. So the direction of the velocity is the direction of the motion of the object. So this is kind of an important thing. So if they ask you what direction is the object moving in, you actually find the direction of your velocity vector, and that will give you the direction of motion. So remember how to find a direction. It's that inverse tan of y over x. So that gives you your direction of motion. The magnitude of velocity is speed. So a lot of this is a recap from last year just with vectors. So if your position, x of t, y of t, velocity is x prime, y prime, acceleration, x double prime, y double prime. Direction is the inverse tan of the velocity of y prime over x prime. Speed is the magnitude of velocity. And I have a little note here because every single one of these formulas can be extended to 3 dimensions, right? So with the exception of direction, which we're going to talk about later. So if you had, say, instead of just x, y, you could have, I'm just going to talk it. If you have x, y, you could have x, y, z, right? And then x prime, y prime, z prime, x double prime, y double prime, z double prime. It's all the same. Your speed, again, magnitude of velocity would be the square root of x prime squared plus y prime squared plus z prime squared. So all of this, if you're in 3 dimensions, you're just adding a third component to your vector. So, oh, you need to go back still?
Are you serious?
I know.
I'm almost done.
He was, you know what? He was enthralled by the story, and I got distracted. So, yep.
That's your fault.
Okay. All right. For r of t equals 3 cosine t, 2 sine t, I want you to find the velocity vector, the acceleration vector, and the speed. And then kind of stop there. Find velocity, acceleration, and speed. And then we're going to sketch a graph of the path of the object as well as the velocity, acceleration vectors at the point 3, 0. So go ahead and take a minute, find velocity, acceleration, and speed, and then we'll continue from there. All right. So velocity, derivative of position, -3 sine t, 2 cosine t. Any questions on that? Acceleration, good. And acceleration, derivative of velocity, -3 cosine t, -2 sine t. Any questions on that one? Speed is the magnitude of the velocity. So speed would be the square root of 9 sine squared plus 4 cosine squared. Or, as several creative minds over in this area said, hey, you could pull 4 sine squared out and have it be 5 sine squared plus 4 sine squared plus 4 cosine squared, and then the 4 sine squared plus 4 cosine squared is just 4, and you have 5 sine squared plus 4, which I thought was kind of a cute little trick, right? But it really doesn't make your life that much easier. But, you know, you could if you wanted to. All right, so so first we need to find the t value. Yeah, we need to. So let's go ahead and find the t value. So you have the point 3, 0. Take a moment, see if you can figure out what t value we are dealing with. Is it 0 or is it pi over 2? Are you sure?
I'm not sure. Oh wait, I thought it was.
All right, I can't write on the board, so I'm gonna write over here. So we get
Oh yeah.
3 cosine t equals 3, right? So we have we need an angle where the cosine is 1 and where the sine is 0. It would be 0. Okay. All right, so we are at the angle of 0. I have a question. If this graph was the graph of 3 cosine t, 3 sine t, what shape would it be? It would be a circle. But it's not. It's 3 cosine t, 2 sine t. How do you think that's going to affect the graph? What do you think it is? It's going to be a what? Elliptical. It'll be elliptical, right? A smushy circle. So, yeah. All right. So, so I personally, I have the graph under here, I'm pretty sure. If I don't, I'll sketch it over there and just tell people. Anyway, so when you have to draw your vectors for your velocity and your acceleration, just plug in the numbers, right? Get your vectors, plot the point, and then just go from that point out in these directions, and you'll see where they go. So, so here we go. So here's our graph. So you get this, the oval or the ellipse or the squishy circle, right? By the way, how is it's smushier this way because the x value had a 3 and the y value had a 2 coefficient, so it's a little bit bigger horizontally than vertically. So if your point is the point, if your point is the point 3, 0, which is right here, so from 3, 0, we would go 0 left or right and 2 up, right? And that would be our velocity vector. From the point 3, 0 for acceleration, we would go 3 to the left and 0 up or down, right? So you get this guy right there. Does that make sense? So you're going to have to, in your homework tonight, they make you find position velocity, they make you find velocity, acceleration, speed, and then they have you, it's a multiple choice, where you pick the graph with the vectors for velocity, acceleration at a point. And really, I just plot the point and then use my velocity vector and say, all right, which way did I be going? Just so you know, velocity, you don't really have to think about it too much because velocity is the same as r prime, right? and r prime is the same as your tangent vector. So velocity should look just like the tangent vector, right? Acceleration should be in the same direction as the normal vector, so acceleration usually points into the curve. All right, that was a lot on that one. Okay. Oh, fun. So suppose the acceleration vector is 2, 0, 3. Find r of t if v of 0 is 0, 4, 0, and r of 0 is 0, 0, 0. Just fun with antiderivatives. So take a moment. All right, so first thing I would do is find my antiderivative of a of t, right? So the antiderivative of a of t is v of t. I went ahead and embedded my constants in. So my antiderivative of 2 is 2t plus c sub 1, then 0 plus c sub 2, and then 3t plus c sub 3. Since v of 0 is 0, 4, 0, so you're plugging in a 0 for all of your t's, then your constants end up being 0, 4, 0. So once you get that, your final v of t vector is 2t, 4, 3t. Then you anti-differentiate again, so you get t squared plus, did I call it k sub 2? Yeah, k sub 1, 4t plus k sub 2, and 3 has t squared plus k sub 3. But since r of 0 is 0, 0, 0, your constants end up being 0, 0, 0. So your final r of t is t squared, 4t, and 3 has t squared. So those are kind of fun. They're the same as what we did before with the double primes and the primes, just with PVA. All right. Any questions on this one? Some for no constants? All right, it's time. Now, if we don't get to this all today, it's okay, because none of this is in your homework tonight. This is all in tomorrow night's homework. So we're going to start this today, and we're going to work on it a little more tomorrow. All right? It's just a big formula. Okay. You should not be scared. It's going to be okay. So this is projectile motion ignoring any air resistance. So we let h sub 0 be the initial height, v sub 0 is your initial velocity, theta is your angle of elevation, g is your gravitational constant. If you've got all those in place, then the path of a projectile is r of t, which is v sub 0 cosine theta times t. That's your x component. And then those parentheses. Oh, I know why I put the parentheses, so you didn't think it was cosine of theta t. Okay. And then your y component is the initial height plus v sub 0 sine theta times t minus 1/2 gt squared. So all of that gives you your position vector for projectile motion. Now, I had some issues last year with students who took physics who were only given problems where the projectiles started on the ground and landed on the ground. So when I would ask, when does the projectile reach its highest point, they were just taking the starting and ending into the total time, dividing by 2, right? Okay, you can't do that for these because we're not going to start on the ground and end on the ground. So we're going to start somewhere else and end on the ground. So, and you're going to have some really good ones in quizzes where we get to bomb cities, right? So anyway, all right. So
It's on recording, boys.
okay. Yes, we could do some real. I was told we don't do enough real world application, right? Okay, so anyway, we could do it maybe with water balloons or something. Do a water balloon activity where we see if we can predict where the water balloon's going to land. I don't know. It might be kind of fun. Anyway, I'm going to pause. All right, a baseball is hit 3 feet above ground level at 100 feet per second and at an angle of 45 degrees with respect to the ground. Find the maximum height reached by the baseball and then answer the question, will it clear a 10-foot high fence located 300 feet from home plate? So the first thing I have written here is all of the initial information you can glean from what you're given in the problem, right? So the first thing I would say is, what is your initial height? 3, right? So your h sub 0 is 3. All right, do you know your initial velocity?
Yeah.
100 feet per second. We're in feet here. Sorry, it's not meters. So there will be some problems in meters and some problems in feet. All right, so in this case, it's feet. At an angle of 45 degrees, what's the angle? What does that represent? Angle of elevation, so we're going to call that theta, right? Yeah, your theta is 45 degrees. Okay, so we've got all that. We can plug those 3 tidbits into the problem and fill in quite a bit. Also, do we know G? Do we know gravity? Okay, but we're in feet. Negative 32 feet per second squared, right? Okay. All right, so that being said, once you plug all that stuff in, you get this for your R of t. Now you can clean it up because you know the cosine of 45 and you know the sine of 45. But here's my question to you. How are you going to find the maximum height? First of all, is the maximum height an x value or a y value? That's a y value, right? So we want the maximum of the y component. How are we going to find the maximum of the y component? We find the derivative, right? And then we set it equal to 0 and we get our max. So, okay, yeah, we're, and to be honest, guys, you could, once you find the derivative, set it equal to 0 and find your value, it's going to be right. If you want a test to make sure, do a first derivative test or a second derivative test to make sure that it really is a max and not a min, feel free, but I don't think the ball's going, like I think it's going to be the max. So, anyway. Okay. So, sorry, once you've got it cleaned up, did I clean it up here? I did. All right, so once you have it cleaned up, there's my cleaned up version. I want you guys to think of this as like your y. Oh, I can't write on here. Think of, maybe I can do, never mind. Think of this as your y and see if you can find y prime. And then you can use a calculator and see if you can find the time when the maximum height occurs.
Mr. Wenzel's gonna be a witness. It's going to happen now. At first I was just playing around. Maybe forced me to show my hand, aka my fist.
Did you guys all find the time?
Yeah.
Did you find the maximum height?
Right.
Once you have your time, how do you find your maximum height? Plug the time into your y component of your position. Do you need to borrow a brick?
I got 81.
You can always borrow a brick. The bricks are great. They are. They really are. I love bricks. I don't have any other calculator in this room for myself. All I use are the bricks. It
I
takes
got
some getting
81,
used to.
21.25. It looks like a Game Gear.
Yeah, well, you know, it's actually designed for you to be able to hit everything with your thumbs, which is kind of cool. Alright, that's me just talking about stuff. Did you all get around 2.21 seconds, roughly? For T? Yes? Okay. So now to find the actual maximum height, you want to find your y component of your position at 2.21 seconds, right? So the maximum height, plugging that in,
You're wrong.
I'm wrong?
No.
Oh, I got around 81.125 feet, which is why you probably would not want to hit a baseball at a 45-degree angle because it's anyway. All right, so around 81 feet high. So we've done the first question. Now the second question, will it clear a 10-foot high fence located 300 feet from home plate? How are you going to figure this one out? Yes, you need to find the t at 300 when what is 300? When your x component, not x prime, just x, right? We want to know when the position is 300. So we have to set our x position, this guy, equal to 300. Find out what time that occurs, and then plug that into the y and see how high we are in the air at that time. Does that make sense? Okay. I'll give you.
When we can apply like this equation to like a three-dimensional thing?
Not this one. All right. So for the fence, so you first find the time. So you set your x component equal to 300. I got that t was around 4.24 seconds when it was 300 feet away. Then you plug that into your y component. I got that it was around 15 feet. So is it going to clear the fence? Yes, because the fence is only 10 feet high. Is that okay? You got a negative 600. For your y value?
Oh, wait.
Okay, wait. Okay. So you got your, where did you find your actual answer? Okay, that's the first problem. So you did. Oh.
I got it divided by 2.
Okay. So you did 300 divided by 50 root 2. You need parentheses, right?
I got
All right, so two students fell into the trap of no parentheses. Oh, I can't write on here. So be careful in your calculator. If you have to do 300 divided by 50 root 2, that 50 root 2 has to be in parentheses, or it's going to do 300 divided by 50 times root 2, right? So be so careful that you put parentheses around what you're dividing by. Good. Any other questions? Any issues? You ready? How are you doing with the brick? You have to, it's kind of like you learn to love it.
Because it's like everything that matters on this side. Like for like I'm gonna use the keyboard or anything.
Yeah, but the keyboard has your X and your Y and your Z. Like the keyboard has all your variables.
Oh.
That's how you get your variables, is you literally just type the letter. All right. Okay, so digging a little bit deeper. Not a lot deeper. This is really just a little bit deeper. All right. So given that a path of a projectile is that, so suppose we assume that your initial height, your initial velocity, your angle, and your gravitational constant are all constants, which they should be, right? Okay. So if you assume that all of those are constants, oh shoot, you can see the velocity vector. Okay. Find the velocity and acceleration vectors based on R of t. So take a minute, see if you can find your v of t and your a of t, assuming that h sub 0, v sub 0, theta, and g are all constants. So take a minute and find your v of t and your a of t.
Thank you.
All right, so your v of t is just the v sub 0 cosine theta, and then v sub 0 sine theta minus g. So your acceleration is just 0, negative g, right? This is just a big constant. And this is just a big constant. Whoa! Which means your acceleration is always, always pointing down, right? You're always accelerating towards the Earth. So, anyway, okay, good. Good work today.